Thank you, everyone. Thanks for coming. OK, let's just start this. So I'm Milica. I'm Web Digital on Twitter, if that's a place you visit often. And I'm a contractor for Google. I work on web.dev, where I write about performance. So stuff like how to optimize your web apps, if they're loading slowly or you have issues with responsiveness. Web.dev is a place where you can find advice on how to fix that stuff. And if you care about performance, and I really think you should come talk to me after this talk, because I really want to hear what kind of problems are you coming into and how we can help with that. I'm also a Mozilla Tech Speaker, like Marco, and I interned at Mozilla working on a browser engine called Servo. Parts of Servo are what makes Firefox fast today. And Servo is fast because it was written in Rust. Rust can do a lot of stuff in parallel. It's a cool new systems programming language. It's kind of like C or C++, but with memory safety built in. So I got to learn a little bit of Rust a while back, but I'm still a web developer, and I really love the web, so I didn't want to move away from that. This was in 2017, when WebAssembly support had just landed, so I decided to learn a little bit more about it. In short, WebAssembly is a way to run code other than JavaScript on the web. I want to talk to you today about how we got to this point and why we need WebAssembly. I'll explain how exactly is it different from JavaScript, and what does it realistically mean for the future of web development. Chances are you already come across WebAssembly without even knowing it. I'll show you some fun examples and some very practical ones too, so let's get started. In every browser, whether you use Chrome, Firefox, or Edge, code is interpreted and executed by a JavaScript engine, which, until recently, used to run only JavaScript. But what about C, C++, or Rust? JavaScript is simply not ideal for every task that you want to perform. And that's where WebAssembly steps in. You do not write WebAssembly. You compile other, higher-level languages to it. But why would you want to do that? Why do we need WebAssembly? The shortest answer is performance. And there are many, many cases where performance is really important, but I want to start with one very specific. And that's video games. Some of the very first WebAssembly demos were video games. In 2017, Unity ported Tanks to web. And then last year, someone ported Doom 3 to the web. And Epic made a short WebAssembly demo in Unreal Engine 4. This is a Japanese Zen garden with a whole lot of interactive elements. This is a GIF, but I promise you it runs more smoothly in the browser. So what's happening here requires lots of math and careful memory management. Falling leaves, cherry blossom, fluttering butterflies, all of this, to render this, you have to do many, many calculations in every frame. And video games in general have to deal with a lot of stuff. They have to implement physics engines, they have to coordinate audio and video, and they often implement artificial intelligence. That's a lot of work, and it requires a high degree of performance. So this kind of performance was really hard to get from JavaScript. And there's a reason for that. This is a screenshot of the first website ever. It was made over 30 years ago by Tim Berners-Lee. Back at that time, web was mostly text and links. So JavaScript came about as a way to add some interactivity to the web. It was designed to be easy to learn and easy to write. But at that time, it wasn't designed to be fast. So over the years, browser engines added a lot of optimizations in the way they interpret JavaScript. This, in turn, made possible many new applications on the web. We got new APIs that let us do all sorts of things, like dealing with Canvas, with web audio, and different aspects of the web. For example, apps that were previously desktop-only started coming to the web. Gmail is a perfect example of this. It practically came out at the same time as Chrome and its V8 engine. So optimizations in V8 were what made possible having Gmail on the web. And today, you don't even think about stuff like this. You edit documents and send emails from the browsers. But there are still areas where JavaScript performance is a struggle. So video games were an early goal, but not because of video games by themselves. It was because of all the things that having this level of performance will enable. So think for a second about other cases where you need high performance that are not video games. For example, video editing, or maybe music production, or 3D rendering, virtual reality and augmented reality, CAD applications, encryption, remote desktops, and the list goes on and on. But why would we want all of these things on the web? Why is the web so attractive? And I personally think that the beauty of the web is that it's kind of like magic. It just works everywhere. There's no download, there's no installation, and it's got safety built in. Browsers have the sandbox, which keeps the code running in the browser from messing with your file system. You never think twice before you visit a website, but you wouldn't just download the random binary and install it on your computer. And my favorite thing, sharing on the web is as easy as it gets. Links are just clickable strings that you can put anywhere. And we all know that's not how app stores work. So web is really a universal platform that makes your application accessible on almost any device. Today, even refrigerators run browsers. So for us developers, this means we can allow a single code base, and it makes the updates easy. So because of all of these things, web came from this simple platform for hypertext documents to a place where we have all these amazing applications. But fundamentally, it was still powered by a simple scripting language that just wasn't designed to handle all of that. So what does WebAssembly actually bring to the table? Today, I'm going to focus on three things. That's speed, portability, and flexibility. Let's talk about speed first. WebAssembly is a low-level binary format. This is what it looks like. It has a text format that's easy to read, and if you're really adventurous, you can write it by hand, but really it's only meant for debugging. The binary format on your right is what you actually deliver to the browser. So binaries are much smaller than textual JavaScript files. This makes files faster to download, and that's especially important on slow networks. And JavaScript's textual format also means that the browser has to parse it. And parsing is not really as simple as it seems. Transforming plain text into binary format has quite a few steps. There's lexing, tokenizing, turning that into abstract syntax tree, and then turning that into binary format. Now, remember how WebAssembly is binary already? That means no parsing, just decoding, and decoding happens much faster. And another difference is WebAssembly's type system. So JavaScript is dynamically typed. When you write x+1, you don't really have to specify what x is. It could be a number, it could be a string, it could be a Boolean, and you don't even compile that code. You just give it to the browser, and the browser has to figure it out. This makes JavaScript easy and fast to write, but it means that the browser has a lot more work to do. It has to compile and optimize that code, and it sometimes has to do it multiple times if it makes wrong assumptions about the types that you will be using. WebAssembly, on the other hand, is statically typed. So the engine doesn't have to speculate about which types are you using. So most of the optimization happens in the first compilation step before your code even gets into the browser. And another thing that gives WebAssembly a speed boost is streaming compilation. So kind of like you can watch a YouTube video as it's downloading, the same way browser can compile WebAssembly binaries as they are downloading. This often means for very small binaries that they will be already compiled by the time they finish downloading, and it makes them instantly ready to run. All of these aspects make WebAssembly fast, but it's not like JavaScript can be fast. We can write fast JavaScript today, but the thing is, that involves a lot of specific code that you have to write for very specific engine optimizations. And the thing is, engine optimizations are not the same in every engine. So if you write code that runs fast in Chrome's V8, it might run slowly in Firefox's SpiderMonkey. And another thing is, these optimizations change over time. So over time, the code that you wrote for V8 from last year might become not really that fast in next version of V8. WebAssembly, on the other hand, gives you reliable performance across every browser. And I think that's what makes it so attractive. And then third thing is portability. How do you take a thing from one place to the other and make it just work? This was one of the main goals in designing WebAssembly, so let's just go over that design really quickly. So just so we're all on the same page, assembly typically refers to humanly readable languages that are similar to machine code. Machine code is what your processor understands, a bunch of numbers. And every high-level programming language gets translated down to machine code in order to run on the processor. Now, different kinds of processor architectures have different machine codes and different assembly for each of them. Now, if you've been following closely, WebAssembly, even though it's called assembly, is not really an assembly language. This is because it's not meant for any specific machine. WebAssembly is for the browsers. And when you write code to run on the browser, you have no idea what kind of machine it's going to be running on. So WebAssembly is actually a conceptual assembly language that's meant to run on any machine. So when the browser downloads WebAssembly, it can quickly turn it into any machine's assembly. And another thing about portability. To run an application on a device, it has to be compatible with the device's processor architecture and operating system. This means that you have to compile your source code for every combination of processor and operating system that you want to support. That's kind of a lot of work. But on the other side, with WebAssembly, there's only one compilation step, and your code can run in any modern browser. This enables two really good use cases. One is porting legacy applications to the web. And then the other cool use case is having a single code base for multiple platforms. C++ is specifically a good language for this because it's supported practically everywhere, including iOS and Android. And another exciting thing is the flexibility that WebAssembly brings to the web. Until now, JavaScript was the only fully supported language that you could use on the web. But with WebAssembly, us as web developers can use other languages on the web. And even more importantly, other people who haven't been web developers until now can now write code for the web. I think this brings more diversity to the web. It brings people with different backgrounds and different perspectives, and I think it will make the web more interesting in the long run. And another aspect of that flexibility is how WebAssembly can fit into web apps. WebAssembly compiles into modules that you can use in your web applications. They have imports and exports that allow you to work with them, kind of like you would with regular JavaScript objects. You can call WebAssembly functions from JavaScript code, and you can call JavaScript functions from WebAssembly code. So WebAssembly is definitely not a replacement for JavaScript. It's really meant to run alongside JavaScript. And JavaScript is actually really good at a lot of stuff. New frameworks are really efficient with DOM manipulation, and sticking to pure JavaScript will probably be both faster and more efficient in a lot of cases. But because they are meant to work together, you can actually write some parts in JavaScript, things that JavaScript is good at, like UI and user interactions. And then you can have some core functionality, something that requires high performance, written in WebAssembly. And another cool thing is, if you have a performance bottleneck in an existing application, you can now use a language that's specifically designed for that kind of problem to solve it. It really comes down to using the right tool for the job. Fully supported languages today are C, C++, and Rust, but many, many others are in the works. .NET, Go, and Kotlin already shipped pretty decent support. And one language that's really, really interesting for me is TypeScript. Now, AssemblyScript is a tool that allows compiling TypeScript programs to WebAssembly. It cannot be just any TypeScript. It has to be strictly typed. But still, I think this is really cool because as a web developer, I do know a little bit of Rust, but still I'm way more comfortable with JavaScript. And I think that's the case for a lot of other web developers. I definitely don't expect people now to just drop what they were doing and go learn Rust or C. But TypeScript, on the other hand, is something that's pretty familiar for a lot of us, and it makes like a really easy way to dip your toes and start experimenting with WebAssembly. OK, moving on to how this thing actually works. You need a tool to compile your source code into WebAssembly. One way to do that is to use this really old compiler called LLVM. It's modular. It can work with a lot of different languages. And this is like a thing that you didn't have to do with JavaScript until recently. Now with Babel and Webpack, compilation is something that we kind of actually do on a daily basis. And LLVM is a pretty complex tool because it's modular. But there is a bunch of tools that came from LLVM that are easier to use for specific languages. For example, for C and C++, there is Emscripten. And then for Rust, it's even easier. Rust nightly has its compiler built in. So you don't even have to use another tool chain. And then there are other tools that can help you package and publish your modules on the web, like WASMPack. And this is how it works. When you compile your C file with Emscripten, what you actually get are HTML and JavaScript and WebAssembly module. So you need this HTML and JavaScript files because WebAssembly actually doesn't have direct access to web APIs. So not even things like DOM. Even to display the output of your program on a web page, you have to go through JavaScript. So Emscripten sets up the boilerplate code that will enable you to communicate with your page. And then the boilerplate code is loaded in an HTML file. And the output of your program is displayed in a canvas or a text area element. Now, this is kind of complicated, and it's a lot of boring work that you shouldn't really deal with. In Rust ecosystem, there's a tool, WASMBindgen, that can make all of this a lot easier and more seamless for you. But still, it's not the smoothest process. The good thing is that this will change soon. There are proposals like reference types and WebIDL bindings that will make these things easier. So things that are not available today in WebAssembly. And this is actually many, many types. WebAssembly has only 4 types, and all 4 of them are numbers. So today, this means that passing objects between JavaScript and WebAssembly is not exactly easy. If you want to pass a string, for example, you have to encode it into an array of numbers and then pass a pointer to it. There's no access to external JavaScript variables right now. But again, these are the bad parts that will likely change very, very soon. So for now, good advice is to use WebAssembly to offload some big chunks of work. Those are resource-hungry tasks, like maybe resizing images or processing audio streams. And I guess you are all probably wondering, are people actually using this in production today? And the answer is, of course, yes. One of the use cases that I mentioned are open source libraries. So if you ever tried to upload a huge raw image to Facebook, it actually went through WebAssembly code, because Facebook is using this really old C library called libjpeg for compressing images. libjpeg was made, I think, maybe even 40 years ago, and it's really good at what it does. It's been just ported to WebAssembly, and now it's available on the web. And if you ever play an audio or video file on Wikipedia, they're actually trying to use open source codecs for everything. So they've compiled Opus to WebAssembly, and they use it for decoding audio. And another really cool open source library that does a lot of heavy work today on the web is Skia. Skia is in charge of graphics in Chrome and Firefox. It was written in C++, but recently it has been ported to WebAssembly, and it's available as a web playground for testing new APIs like Canvas or SVG things that are new on the web. And another use case that's probably the most interesting for people in this room today, for JavaScript developers, are hybrid apps, where only parts are written in WebAssembly. One example is Squish, which is an app from Google team that's used for compressing images on the web. It uses some really cool compression algorithms, such as MozJPEG, PNG, and WebP. These compression algorithms are implemented in WebAssembly, but the user interface is actually written in Preact. This app loads really fast, and you can test it right now from your mobile phones if you go to this URL on the page. And there are big apps using WebAssembly too. Figma, for example, is a collaborative design tool. It runs in the browser and allows designers to share files and collaborate easily with each other. It was mostly written in C++. It has a really complex rendering engine, and it can handle very large documents on the web. That part of Figma is compiled to WebAssembly, but the other part, its user interface, is actually written in TypeScript and React. And I also mentioned you could port legacy applications to the web. One example of this is AutoCAD. AutoCAD is design software, which is mostly used by engineers for things like floor designs or piping designs or electrical circuits. It was written in C++. It's been around for almost 35 years. That's older than the web itself. And recently, they've been able to port this application with its hundreds, thousands of lines of code to the web. So now it's available in a browser, and they didn't have to do like heavy rewriting work for stuff they've been working on for 35 years. And another example of a legacy application is actually Google Earth. Google Earth was released 14 years ago. It's a really cool application. It allows you to zoom in on your home or maybe stroll from across the world. But these things could happen only once you download and install this app. And recently, this year, they've ported their application to WebAssembly, and now it's available on the web across many different browsers. And there are actually many, many more examples. People are doing weird stuff. Someone ported Windows 2000 to the web, so you can run an operating system in the browser. And yes, you can totally play pinball in it. Another fun example is WasmBoy. This is Game Boy Plus, Game Boy Color emulator that runs in the browser. It was compiled to WebAssembly by using AssemblyScript. And it comes with an interactive debugger, which was written by using Preact. And last year, I was at JSConf EU, and Mozilla displayed this installation called the Arch. It has over 30,000 LED panels that you can control by compiling your Rust animations into WebAssembly. So there are many more fun examples, and there are a lot more practical examples too. Like, for example, you can use WebAssembly to implement blockchain. This is what Ethereum is doing. And then there are cool scientific visualization tools like Iodide that you can use directly in the browser because of WebAssembly. WebAssembly is actually supported in all major browsers. The support is over 86 or 87% worldwide today. And the cool thing is that the browsers are actively working on implementing new features. This is really different from how things were in the past. Some of you might remember these screenshots, and the younger crowd here probably has no idea what this is. It's Flash and Java applets. And you don't see them around anymore because they are dead. So these technologies were pushed by competing companies, and they were never actually a standard. They never made it to be integrated into the web. Companies have competing interests, and I think that's what eventually was the demise of these technologies. But WebAssembly, on the other side, has a standards committee, and all browser vendors work together on implementing new features and agreeing how to proceed forward. So I think this is something that's going to enable WebAssembly to keep evolving and to stay backwards compatible. So the important stuff. What are actually the benefits for JavaScript developers today? I actually think this integration will make JavaScript even more powerful because it will give us access to all the best modules from all other languages. I think JavaScript, in part, expanded so much because of the ease of distributing modules. And NPM was a big part of that story. So WebAssembly modules are actually already available today through NPM. There's over 600 of them. And OK, so what if you really don't think you're going to use it? You have no plans to make a video game, no plans to make the next Photoshop, or ever touch any WebAssembly module from the NPM. Well, I think you can still benefit from WebAssembly because of the speed boost that it brings to the tools on the web. This is already happening. Firefox DevTools and Webpack are both using source maps library. It was recently rewritten in Rust and compiled to WebAssembly. This rewrite gave it an 11 times speed boost. And these are tools that a lot of us are using every day. And framework can also be improved with WebAssembly too. So Ember is already investigating how to implement its Glimmer virtual machine in Rust. And then some parts of React could really benefit from being written in other languages. Like React's diffing algorithm could be easily parallelized and made much faster. Rust is a good language to do parallel stuff, and you could compile it to WebAssembly and use it on the web today. So what else is there? What else can WebAssembly do? It has actually started expanding beyond the web. WebAssembly runs inside browser engines, but as I mentioned, it's a conceptual language. So you could create other runtimes that can run WebAssembly. And that's exactly what's happening. Cloud providers like Fastly and Cloudflare now run WebAssembly in the cloud. This allows you to run WebAssembly as a serverless function. Most cloud providers today allow you to work with Python and JavaScript, but with WebAssembly, this opens the doors to using many other languages. And the benefits of serverless kind of stay the same. Things that it allows you, like pay-as-you-go model, and being able to scale automatically. So this WebAssembly thing obviously works, but it's going to get even better. Let's see what lies ahead. as I said, browsers are already working on new features. Threading is already available in all Chromium-based browsers, and it has been implemented in Firefox too. It's just been disabled for security reasons. It will probably come back pretty soon. Support for garbage collection is coming in Firefox sometime next year, and this is a really cool thing because it will make WebAssembly a better target for languages that use garbage collectors, such as Java or C#. And one really important tool for WebAssembly are better debugging tools. So you could view your source code directly in the browser. And support for ECMAScript modules is coming too. So you wouldn't have to deal with all the boilerplate code. You could just type in script type module and access your WebAssembly code. So if all of this sounds at all interesting to you, I think you should just try it out. If you want to just poke around, there are a couple of web IDEs that allow you to experiment with WebAssembly without dealing with any of the compiler toolchains. One of them is WebAssembly Studio, and there are already some Hello World examples that you can try compiling. They're written in either C, Rust, or AssemblyScript. And another cool web-based IDE is WebAssembly Explorer, where you can actually peek into what's under the hood, into WebAssembly binary type and its textual format. And I think you should all come tomorrow to Kirill's talk about what's actually inside WebAssembly. And the Arch that I've mentioned actually has a web interface where you can submit your animation written in Rust and compile it to WebAssembly directly. So at JSConf EU last year, you could actually see your animations running on that Arch. But WebIDE is available, is still available even though the Arch is not on the display. So I think this is a cool, fun way to try out WebAssembly. It has a 3D model where you can preview animation, and then maybe next time when it's on display, you can see your animations live. So this is Armada JS, and I just want to say again that I think JavaScript is a great language. It's flexible enough to write almost anything. It will still have its place in web development. It's just those parts where it doesn't perform well can now be filled in with WebAssembly. To end it on a positive note, I really don't think that WebAssembly is the end of JavaScript. I think it's a new beginning for the web. Thank you so much for your attention. If you want to learn more about how WebAssembly works, I really recommend Code Cartoons by Lynn Clark. And if you want a recap of this talk, you can check out my article, WebAssembly, How and Why. This is the URL for your questions. So hvala vam na pažnji, and come see me later at the lunch break if you want to talk about anything related to WebAssembly or performance in general.
All right, thank you, Milica. So people, you asked questions, you voted for your favorites. So let's start with the first one. What do you think about using monads and other end of functions in WebAssembly?
So functional languages are not really my expertise. So no, I really don't have an opinion on that. But definitely, like whichever language are you using that supports functional paradigm, you can port it to WebAssembly too.
OK, thank you. Next one. You're the first non-Microsoft person I have seen speak on WebAssembly. What are your thoughts on Blazor and its efforts to bring the .NET runtime to the browser?
Oh, I actually think it's doing very well. And a lot, it's been progressing. The support is pretty decent today. And actually, there's like an anecdote a while back where people, a backend team who was proficient in C# wanted to have their application run on the web. And they weren't really good with the UI. So they were considering to use Blazor to just write the UI themselves. And this is the thing that I was talking about, bringing more people to the web, bringing more web developers. And these were C# people. So they actually ended up not doing that. They hired a React developer, but this was last year. I think today, this is actually feasible. And I think C# will pretty soon become like a really good target for WebAssembly. So yeah, I think it's a good idea, and it's going to happen very, very soon.
Okay, thank you. Next question is, I want to start writing/learning WebAssembly, exclamation mark. Where do I start? What to learn? You touched on that a little bit, if you have anything else to
Oh, I
add.
do have something else, and this is actually my favorite question. So if you want to just start experimenting with this technology and want some exciting project to work on, I can suggest games. Like take some old school game that you think is cool or fun, something even as simple as Space Invaders, rewrite it in a language that you are comfortable with, and then port it to WebAssembly. I think video games are really cool projects to start with, and old school games like Space Invaders are really not huge scope projects, so you can get it done like in a month or so. And another, maybe like an example that takes a little bit less effort to get started with WebAssembly, is just like go dig through old C libraries and see something that excites you that you would like to try on the web. Like rendering and graphics are good examples because you can see the thing that you're working with. So yeah, maybe just find some cool C library that does rendering and port it to WebAssembly. You'll probably run into some hitches, and that's actually the fun part. You know, you'll learn a lot about how to compile things.
Okay, thank you. Next question. Can WebAssembly programs and JavaScript somehow communicate with each other?
Well, this is actually kind of thing where you would want to have one program that runs both JavaScript and WebAssembly. And yes, they can communicate to each other. Like JavaScript functions are called from WebAssembly, and WebAssembly functions are called from JavaScript.
Fair enough. Okay, thank you.
Yes, I guess.
We have another question regarding how to start with WebAssembly, so maybe we can skip that and go to the next one. And that is, how is it different than plugins for the browser, like Silverlight, Java, etc.?
Exactly. So how this is different is the thing that I mentioned, the standards. So Java was a Java thing. It was not a web standard. And it was pushed by like just one company, and that's the thing. Other browsers didn't want to keep up, and this thing was just a plugin. But WebAssembly, on the other hand, it has standards. So kind of like things that come to ECMAScript every year, every browser has to agree which features are going to get implemented. And it's the same thing with WebAssembly. And I guarantee you, all browsers are very committed to making this technology work. So I think that's the thing that's going to make it different. The unilateral support it gets from each browser vendor.
Okay, thank you. Next question is, what is the security model for WebAssembly?
Right. So the security model is the sandbox, like the browser sandbox. WebAssembly relies on its security.
Okay, thank you. And I would close this Q&A session here. For any additional questions, just reach Milica after, anyway, we have lunch break after this. So, yeah.
Yeah, definitely. Come talk to me about anything that interests you, like performance, contributing to open source, or anything WebAssembly related. I really love to meet all of you, so I'll be here both days and really hope you'll come talk to me. Okay, thank you so much for your attention, and enjoy lunch in these 2 days.
Thank you.